Hey, we're back in the barn. So we were talking about functions before, and we're going to continue to talk about functions a little bit more over the next couple lectures. 1.4 is function notation. So now that we've decided like how to figure out if a relation is a function, now we need to use notation. So we're in 1.4 function notation. And basically what we're going to do is we're going to look at our two variables, our x and our y, and we're going to let x be our independent variable. So the independent variable is the variable that you get to choose. So in the last lecture, I said something like, if x was equal to 1, then we know what y equals. Well, that x, by just saying, hey, I'm choosing x to equal 1, that's our independent variable. We get to choose what that is. So we're going to let that be our x variable. And then our dependent variable will be our outcome, or what do you get? So if I tell you that x equals 1, what's the answer going to be? What's the y value going to be? So we have the independent variable x and then the dependent variable y. And if we have this situation, so if we can say, if y depends on x, then y is a function of x. So that dependency and function go hand in hand. So y depends on x means y is a function of x. And when that's the case, we use what we call function notation. And function notation is written like this. F and then a parenthesis x. And it said f of x. F of x. And so when we are writing equations from here on out, we can, or sorry, not equations, equations that we know are going to be functions, instead of writing like y equals x squared plus 3x, I now can use this f of x notation. So in place of the y, we put f of x equals x squared plus 3x. Right? And that's just telling us that this equation, this part, has this dependency going on, that the answer depends on what x values were given. This also allows us to write our answers in a little bit more simplified notation. So in the last lecture, I said, if x equals 1. Well, if I want x to equal 1 here, what I'm going to do is I'm going to plug it in to where the x is in the function notation. So I'm going to say f of 1. And what that tells me to do is to take 1 and plug it in everywhere where we see an x. So we'll go 1 squared plus 3 times 1. Okay, so this is not multiplication. It's telling us to do a substitution. So we're substituting in 1. And then if we simplify there, we'll have 1 plus 3, which is 4. So f of 1 is equal to 4. So as soon as I give you that 1 to plug in there, though, you then know what the answer is going to be. So, I mean, it seems kind of dumb, but I could ask you to plug anything in there. I could say, find f of heart, in which case we're going to have heart squared times 3 heart. So all that notation is a substitution notation. It just says to go ahead and plug that, whatever is in that parentheses, into the formula, or into the equation. Now, one that we may see, or very rarely are we going to see f of heart, but we may see this. Find f of x plus h. So what that's asking us to do is to take x plus h and plug it into the equation. So we're not actually plugging in a number here, we're plugging in another kind of little equation into the big one. So this one would look like x plus h squared plus 3 times, and then we're going to put another x plus h. So anywhere where there's an x, instead of it just being an x, we're putting x plus h. So again, that substitution there tells us what to plug into the equation. Now, in most cases, we do want to do some simplifying or some multiplying out. So, I mean, obviously with the hearts, there's not much we can do, but here we simplified and got 4. This one, we can actually multiply this out if we think about foiling it out or putting another x plus h there. If we multiply out, we'll have x squared. And then for the inside terms, we'll have xh and xh, so we'll have plus 2 xh's plus h squared. And then here we can distribute in this 3, so we can say plus 3x plus 3h. Now, that didn't really get much simpler. It actually got uglier. But if it asks you to perform the operation, so if it asks you to plug this in and then work out or expand or multiply or something like that, it's actually asking you to work out the problem. Doesn't look prettier, but what are you gonna do? Okay, now, if we have a second function on the board at the same time, we might use a different variable for that. So we might see something like g of x equals the square root of 4x minus 3. So now, if I want you to plug 1 into this particular function, I am going to say find g of 1. And now over here we had f of 1, and that went into this function, but by noting it like this, it's telling us to go into the function that's named g. So you can use different letters, f, g, h. Those are common letters that we use for functions. So here, it's just clarifying where to plug in the 1. So we're going to plug it into the square root guy. So we'll have 4 times 1 minus 3 under the square root. So that'll be the square root of 1, which is just 1. So in that particular function, g of 1 is 1. In this particular function, f of 1 was equal to 4. Okay, so looking then at function notation, you're going to see they're going to ask you to plug in numbers, they're going to ask you to plug in different things that aren't numbers, so you're going to see some of this. But one other thing, again, might be new for some of you guys, is what we call piecewise functions. These guys are a little bit different, piecewise functions. So let's say I'm going to call it h of x, just for the heck of it, h of x. Let's say that h of x is not just one particular equation or another particular equation, but let's say that it's made up of 2 parts. And this can happen. It can be made up of 2 parts, 3 parts, a lot of different parts. So when we see something like that, we're going to see a function, and it's going to give you this squiggly bracket. And then it's going to say something like 2x plus 8, and then it says if x is less than 0. And then it might say the absolute value of x minus 3 plus 4 if x is greater greater than or equal to 0. So this function is made up of two smaller functions tied together, two pieces tied together. And we've got to be given the interval where they are tied together. So this one, if x is a negative number below 0, then we're focusing on this part of the graph, or this piece of the graph or the function. But if x is greater than or equal to 0, we're focusing on this one. So let me erase this stuff over here real quick. Let's see if our eraser works. Ooh, it's working. So let's say that I asked you to find h of 3. So h of 3, again, telling us that we're using this piecewise function rather than this guy, because that guy is g and this one is h. But now, because it's got the two parts, before we just jump in, we have to decide which one of these parts we're going to use. So we have to focus on the number 3 here, and notice that that's in this area, isn't it? X is greater than or equal to 0, which means that we're going to use this part of the equation. So we're going to use the absolute value of x minus 3 plus 4. So we're going to plug in 3 in there, absolute value of 3 minus 3 plus 4. Now 3 minus 3 gives us 0, and then the absolute value doesn't even really matter. So honestly, this part just kind of cancels itself out. So we end up with just 4. Okay? So h of 3 is equal to 4. But what if I asked you to find h of negative 3? If it's h of negative 3, then are we going to use this guy again, or are we going to go to the other one? This one is the one that we use when the x is less than 0, so we're going to use the 2x plus 8. So we're going to say 2 times negative 3 plus 8. So we've got negative 6 there, plus 8 gives us 2. And then one more of these guys. Let's say that let's say that I'm asking you for h of 0. Which one of those two guys are we going to use if we're looking at h of 0? So the inequality now becomes very important, doesn't it? So here, this is the one that includes the 0. So this is the guy, this one is the one we'll use in this case. So we're going to take 0 and plug it into that absolute value. And that's going to give us the absolute value of negative 3 plus 4. And the absolute value of negative 3, remember absolute value makes it positive, so it's 3 plus 4, which is 7. Okay, so we're going to start to see these piecewise functions start to pop up. So they start in this one with the function notation, because it definitely is a notation situation. But as we go on, we'll start to look at some graphs with piecewise functions and some specific special piecewise functions as we get a little bit more into this. Okay, but this section really is just about using the f of x notation, or g of x, or h of x, whichever one you want, and then plugging in the values into the function. Okay. All right, so that's a nice little short one there. Okay, I'll see you next time.